A very good morning to each one present. Today, I, Dev Mehta, on behalf of FIPI PDEU Student Chapter, welcomes you all to our data science workshop. This workshop will be focusing mainly on how data science can help to solve petroleum engineering problems using Python. Now, I would like to welcome to our speaker, Mr. Jaiyesh Chahar, who is currently working as a data scientist in Siemens. He is also the co-founder of Petroleum from scratch. We are grateful to have you with us for this learning opportunity. So without any further ado, I would like to request our speaker, Mr. Jayesh, please begin with the session. Over to you, sir.
Thank you so much, Dev, for the introduction. Hello, good morning, all. I hope everybody is doing good, having great time, listening to good music, learning new skills. So this session is going to be not a complete workshop. This will be more of an interaction where I will show how to what will be the footsteps, how a petroleum engineer can get into data science industry or AI industry, or how he can learn a new skill that can help him to solve petroleum problems itself. Okay, and I'm also expecting a lot of replies from your end, also lot of queries from your end. So that will be beneficial for you guys. If you have any doubt, you can ask in between also. And yeah, let's start the session. And also, basically, this is the session for knowing how to get started. Okay, and I will share the links also from where you can get started or the things. So before moving on, my first question: how few knows exactly what is data science or have a little bit knowledge about programming, coding, Python, something? You can type in the chat box. Or all of you are completely new to this particular field. Okay, I can see Ananya's hand. Home's hand too. Three. Okay, so you guys know programming a little bit, or do you also have idea about AI, ML? How does it work? So I can get a brief about how many of you are new. So yeah, it seems like many of you are new, only two, three people know. So let's get started. By end of this session, you guys will know if you want to build a career in data science or ML, how to get started. Okay. So I'm sharing my screen. There will be one PPT. The PPT is so footsteps to data science in oil and gas industry. So first question before moving on to that, what is data science actually? So data science is nothing. Data science is basically, if we get deeper into data science is uh, getting the story out of your data, right? And this data can be anything. And how do you get the story out of that particular data? By using mathematics. So behind any particular machine learning or artificial intelligence algorithm, there is only mathematics. There is a lot of matrix multiplication, there is differential calculation, all those things. I think all of you guys know ChatGPT, right? Yes or no, you can type in the chat box. I'm saying side by side. Yeah, so ChatGPT is also AI model, large language model. It is known as large language model. So behind the hood of ChatGPT is also mathematics going on. When you get deeper into the field, you will know, okay, and at the last you will know, you will get to know that, okay, this is only matrix multiplication and differential calculus going on, nothing else. So data science is basically getting meaning and insight from your data by using mathematics, statistics, and computation power. Mathematics and statistics is clear, right? That differential calculus and all those things are needed. But computation power, one of the major reason that data science is rising in these particular days. Just give me a second. Yeah. Data science is rising in these particular days is also due to rise in computation powers. High computational powers or high computational GPUs are available. And again, when you are developing a model, what is a model? I will tell you in a little bit. When you are doing a data science, let's assume, let's speak in simple words, when you are doing data science, a lot of computation power is needed. A lot of computation power is needed. For what? For calculation. For calculation. As I said, mathematics and statistics is going on, so calculation need to be done. So for these particular calculations, a lot of computation power is needed. And after 2010, after 2010, there is a huge rise in the this particular GPU industry. Huge rise in GPU industry. Is a lot of innovation that happened in GPU industry that also skyrocketed your data science or AI/ML. Okay. So that particular thing is data science. Now, many of you will get confused that, okay, you have here different words, data science, machine learning, deep learning, all those things are different. So basically, if you can see this Venn diagram, artificial intelligence is a thing, a larger thing. And inside that, your machine learning and deep learning, these are subparts of that. And data science is using all these techniques with the mathematics, statistics, and visualization of data. And again, this particular thing also I will kind of show in a little bit of time when we will open whiteboard. But this is a major difference between AI, ML, and deep learning. And machine learning, basically machine learning algorithms are also tools of data science that helps computer to learn from data. What exactly that means, I'll tell you. So this is basically basically data science, getting the information from your data. And how do you get the information? By using mathematics, statistics, visualizations, and some of your machine learning algorithms over the data. Okay. Now, the next question will come, why data science in oil and gas industry? Or before going to data science, I will tell why even Python in oil and gas industry, why a petroleum engineer should learn should learn programming, right? So what is happening now in the industry? If you can see, there is a lot of digitalization is going on, right? So all the companies, Schlumberger, Halliburton, all those have their softwares also for doing your simulation and other things, right? So a lot of digitalization is also going on, and data quantity is also increasing, right? Now, for telling why coding, right? Why coding? So as digitalization is going on, if a petroleum company, any petroleum company, let it be XYZ, decide to create its new software or a new simulation tool, right? So it will require software developers and petroleum engineers also, because petroleum engineers will have the knowledge of core and software developer will know how to code. So it will require two people. Now, if they are able to get these both of these skills in one person, that will be beneficial for this particular company, right? And also it will be beneficial for this particular guy also, because he can get you can say he can kind of negotiate for more salary, and also his skills will be unique in the industry, right? He's kind of doing a job of two-person, right? And because only software developer is also not able to uh, write the complete simulation code without knowing what exact physics is going behind the scenes, what exact physics is going behind the processes. And a lone petroleum engineer doesn't know coding, so he was not able to do anything. That's why it's important, and in coming days, in coming years, it will be important to learn coding in all the domains, no matter it is oil and gas industry, petroleum engineer, mechanical engineer, civil engineers. It will be important to know coding. And nowadays, this particular coding thing has become so much easy. After the arrival of ChatGPT, you just need to mention that what you want to do, and it will directly give you code. So you just need a little bit time to learn coding, right? So that's why coding is important. Now, why data science is important? Now, what is happening? As I said, data volume is increasing in all the industry, not only oil and gas industry. In oil and gas industries, it's also increasing, but across all the industries, data volume is increasing because we have different sensors, different data acquisition techniques. So that's why data volume is increasing. Now, if we have more data, we can use that for doing something, for solving some particular application. For example, I will give a example here. It is written here also that in the past years after 2013, after 2013, your development of unconventional reservoirs like shale gas, shale oil has been increased a lot, right? And we don't know exact physics behind those particular processes, how a shale oil is being produced, what exactly physics is going on inside the pores of shale. As we know about the about our sandstone and limestone, right? We know Darcy law is going on and different equations are going on, but we don't know exactly what is happening inside these unconventional reservoirs. But we have a lot of data about them, about their production, about their reservoir. Now, until unless this research is going on about the physics, what we can do, we can use this particular data for solving that particular problem, for kind of developing a reservoir simulation tool using completely machine learning or data science, because we have a lot of data about that. We don't know exact physics right now, but we have a lot of data, historical data, and historical data will always repeat itself in future. Right. So for these types of problems can be solved by using data science. There are different applications also I will show in a couple of minutes. So you can solve them by using data science, or more of data science, I will say AI, because AI is the complete superset. So AI in oil and gas industry. Now, again, here this particular thing will arrive while also doing a AI use case AI use case in oil and gas industry. Now you guys will say that, okay, we already have these particular CS people, computer science people who know AI. So why do we learn? Now they know AI, right? But they don't know what exact is happening in the data, right? You guys will have a good understanding that, okay, what are the properties of unconventional reservoir instead of these particular CS people. So again, you will have a upper hand there. And also there is always it is said that you should never stop upscaling no matter what, right? So this is kind of answer to why data science in oil and gas industry. Anybody of you have any doubt till here, till this point? Can raise your hand or ask before moving on. Yeah, go on.
So generally, I don't know if it's true or not, but what I've heard is companies often hire, the companies which are already doing data sciences and all. So
Yeah.
will it really be, fruitful for a single individual to, do a multidisciplinary thing? Because if there's an already existing firm or companies are doing that, so it's better to focus just on the core where, multidisciplinary conflicts are not there. Like, I'm a little confused about it.
Okay, I'll give you an example. Okay, and main
Yes, sir.
purpose behind all these things are for getting a job, right? Behind all those things. So your
Right, sir.
studies, your college. If at the end of the day you have job, you are good, you are winning. So what happened in last 1.5 years, 1.5 years back, Accenture got a project from one of oil and gas giant. I will not name the giant. So they started to search for data scientists who know petroleum engineers, and trust me, they hired more than 20 people who know petroleum engineering, and those were freshers. Data scientists who know petroleum engineering, or you can say vice versa, petroleum engineers who know data science.
Okay, okay, sir.
Okay, and 2 years back, today in today's world in 2023, crude price is good, so oil industry is in good shape. But 2 years back, oil industry was not in a good shape. COVID just
Yeah, right,
hit
sir.
us, and it was in the price of crude was in negative.
Right.
And it is, you all guys know, crude market is a volatile industry, so it's always better
True,
to
sir.
have some backup.
Right, right, right. Thanks.
Answers
Thank
your
you, sir.
question.
Yes.
So now some of the applications of data science or ML that you can do in oil and gas industry. These are some of the list of use cases. And more of the use cases you can find on internet on one petro. If you go on one petro, just search machine learning, reservoir engineering, you will get a lot of papers, research going on. You can read them, how they are using different techniques for solving a petroleum engineering problem. So here are some of the applications. Seismic data and geological data you can use to predict the oil. pockets nearby. You can also do the trajectory forecasting using drilling data that, okay, how your trajectory is going to look like inside a well if you have enough drilling data. You can do predictive maintenance, a very good project in the industry at the moment, in all the industry. So all these equipments of your drilling rig or production system will have some life related to them, right? That after 10 years, a particular drill pipe will not be used, or after 2 years, a particular drill pipe will not be used, 10 years drill bit will not be used. So predict that, okay, when will a particular equipment will need maintenance, that particular thing is known as predictive maintenance. So that beforehand, there is, let's assume there is mud pump inside a drilling rig that's been working since 3 years, right? And it is of company X, and let us say what was it? It is of company X mud pump type Y. So if I have enough data of this type of particular equipments, enough historical data in which these have also failed, I will know that, okay, from the past 3 years, it's working in these particular conditions. Let's assume pressure, temperature, we are getting from sensors. In these particular conditions, how much more time will it survive? Let's assume this particular pump has four parts, four different parts, A, B, C, D. Rotor, motor, all those different parts are there. And we have information about all these particular data from historical data, also historical data of all these types of pumps that have been installed somewhere in other rigs or whatever. Now, if I have this type of data and if I do this particular predictive maintenance project, I will get to know that, okay, in coming 7 days, this particular C equipment of this particular pump is going to fail. I know 7 days prior to that, right? So I have enough time to call my technician or to order this particular C equipment so that my downtime can be reduced. 7 days prior, I have already planned that, okay, I need this particular equipment, I need technician who will change this. So all things are done, right? Now, if that particular equipment is going to fail even in the 6th day or 8th day, I've already prepared. Whenever it will break down, I will just replace the equipment. Uh, I need not to keep down the complete process itself, right? I need not to stop the drilling. So I have raised the economic production, or economically, I have benefited my company, right? So in that way, you can use this particular thing, and that particular thing is known as predictive maintenance. So basically predicting the predicting the failure of a particular equipment. A very good use case. It is going on across multiple different companies are solving this particular problem. EOR screening you can do. EOR screening, everybody know, by using physics. I think there was this paper of EOR screening that came out several years back. So physics rule based, everybody knows, but by if we have enough data of different field across the globe, we can use both your physics based rule also, and data analytical side also, and we can and by mixing both of them, we can get better result. Pressure prognosis in well testing. So basically, what exact this particular term means? Everybody knows well testing. Yes or no, guys? Well testing, you know. Getting only one person know well testing. So what happens in well testing? We kind of shut down the well, right? Getting to know about the parameters of our reservoir, permeability, wellbore storage, and how much is the radius of my reservoir, all those things. And also for maintaining the pressure. If a pressure is decreasing, we need to shut down our well for getting a kind of higher pressure so that pressure can be built up. Right. So now what happens if we again in a particular reservoir, let's say I have this particular field. And this is my wall field, right? This is my wall field. These wall field have different wells, right? All wells are producing, And let's assume these are producing from 2010, 2015. Now I drilled a new well here, right? And I started production. I have data for all these well. I have build up data, well testing data, all types of data I have for all these well. Now I need to shut down this particular well so that my pressure nearby or pressure in the vicinity of this particular well kind of build up to certain level. If I have historical data of this particular well, that okay, if in this particular reservoir, if average reservoir pressure is going to be around 200 psi, and if we shut down the well for 10 days, it will reach to 250 psi, right? If I know that particular thing, I will tell that okay, if we need to build the pressure to 250 psi, the nearby well has been done this particular thing in 10 days. So let's also close this particular well for 10 days. So this particular thing is known as pressure prognosis. In how much time, if I shut down a particular well, my X pressure will build up in the well. So again, this thing can be done. I have said this particular thing in simpler terms that okay, in 10 days it will run. But again, here also a deep learning algorithm will be used so that it can get the information out of historical data. Then there are reservoir fluid properties estimation, selection of artificial lift, just like your EOR screening. We have efficient enough data of artificial lift techniques used across different fields across the world. We can select the artificial lift for a new field. Production forecasting you can do all these things. So these are some of the application. Here I have written more applications. Yeah, I will share this PPT. You can go through the applications by yourself. Basic need is if you need to have enough data, you need to have code knowledge, you need to have coding knowledge, and you will be able to solve anything. Once you have data, you can kind of derive your own application from that particular data. Now, this is a particular summary of machine learning algorithms. This again, I will tell in a couple of minutes when I will open my whiteboard, what will be the complete process or complete, you can say this particular pipeline, how to start, what to do. So yeah, let's get started on that. So first point, how to get started. You're a petroleum engineer, how to get started. In AI. First step will be learn Python. Learn a tool. You can learn any particular coding language. You can learn C++, you can learn MATLAB. Why I'm saying Python? Because Python is used a lot across the industry, in AI industry as well as everywhere. Python is kind of more preferred nowadays because it has a lot of community support. Learn Python, learn basic Python. From where to learn, I will share. Learn Python, okay? So across this Python, there will be multiple things. There will be core Python that will have simple concepts like your if-else loop, variables, different loops are there, different conditions are there, functions are there, exception handling are there. Handling. Sorry for my handwriting. Once your core Python is done, then move on to some of the data analytics library. What are these libraries? There is this NumPy, numerical Python, where you will start to deal with arrays and matrices. Arrays are basically your matrices. Your first point, your first step towards AI will be this particular thing. Matrices and all. Then learn pandas. What is pandas? You can say it is a strong version of Excel in Python. So you will have data, and I'm talking about tabular data right now. There are different types of data. Data is there. Image is also a data. Voice is also a data. Text is also a data. Tabular data is basically that has tables. For example, your Excel sheet, CSV sheet. So for reading, analyzing, and manipulating is an important word. Manipulating your tabular data, pandas will be needed. So it is a strong version of Microsoft Excel inside your Python. You can read your data, you can analyze, you can do different analysis on your particular data, that okay, how your data is looking like, how many missing values are there, and all those things. And you can manipulate your data by using pandas. Your next step will be learning plotting library. You know arrays and all, you know how to read a data inside Python. Now plotting will be needed because you have to do data analysis, right? So it's always better to see your data in terms of figures instead of seeing the data in terms of sheet. So plotting libraries will be needed. There are plotting libraries like matplotlib, Seaborn, cufflinks, etc. No need to learn all of them. Matplotlib and Seaborn, these two will do your job. Now till this particular point, if you reach this particular point, you will be good in data. You will be good in Python. Your Python skills will improve till this particular point. Now what next? Now the next point will be you have done Python, right? Now pick a topic of your choice or pick up a textbook. This textbook can be any textbook. If you are good in reservoir, pick LP okay, or Tariq Ahmed. If you are good in this particular drilling, pick your HRAVIA. For production, pick any other textbook that you like. Right now, for example, I have picked up LP. Now there are multiple of problems in LPD, right? Multiple of your numerical problems in LPD. Now let's assume I have picked up a problem from my material balance and Bell. Material balance, I picked up a problem. Now try to solve that particular problem. You know how to approach a material balance problem, right? Because on papers, on your textbook, you have already solved those particular problems. Now try to build a logic of this particular problem in Python. How you will solve that particular problem in Python? What will be your input? What will be your Python program? And what will be your output? Solve this particular thing. Try to write this particular code that will take an input and give you an output. And it is better to involve a plot inside it. That in the output you will get a plot of something. So it will be a great. So for example, let me show an example for this. Type here. So this is code for your Vogel IPR for inflow performance relationship. So this is a Python code. You guys will know once you start learning it. So it will taking some inputs from the user and it is giving a Vogel IPR picture as an output or figure as an output, that for this particular inputs, your output will look like this. And all the logic that is happening is written in between. I have taken the input, I have calculated the productivity index, I have calculated the absolute open flow, and at last I have plotted my thing. So do this type of exercises. Take a textbook, try to practice Python as much as you can using your petroleum engineering knowledge. Okay. So you now at this point you have implemented a application, implemented a petroleum engineering application using Python. Do as much as you can. So what will this particular thing will help you to grow the confidence in Python. Okay. Now this particular thing is done till here. Till here the part is done. So you are more of a data analyst at this particular point. Now next thing that comes into picture is your mathematics. So start with statistics. Because statistics is needed a lot in data science industry. Starts with statistics. This particular thing is a theoretical part. Start to learn your machine learning algorithms. There are different machine learning algorithms. And these machine learning algorithms are nothing but mathematics and statistics. Once, for example, if I give you an example, there is this one particular algorithm known as linear regression. That is nothing but you have in your high school, or not even in high school, in your 8th, 9th standard, you used to have 2 points, right? And you were told to join a line, draw a line between them. You used to draw a line between them, between these 2 points, and you used to extrapolate them also, right? This particular thing is linear regression, in simple words. So yeah, once you get started with all these things, you will the things will start to come out automatically. Machine learning is done. I'm assuming machine learning is done till this particular point. Now your next point will be open one Petro, or not only one Petro, open anything. Just search on Google AI use case or machine learning use case in petroleum engineering. I'm assuming that let's open one Petro, open a paper of AI ML use case in ML case in petroleum engineering or in reservoir engineering. I'm assuming you are good in reservoir engineering. Okay, so ML case in reservoir engineering. Open up the paper, try to implement that paper by yourself in Python. And if you did this particular thing, you will be unstoppable. You are already a data scientist. There will be no company that will not will to hire you in petroleum industry only. And after that, there will be next steps, because as learning never stops. After that will be steps. You can go deep inside your deep learning. You can start learning deep learning. After that, you will also need to have some of the knowledge of DevOps and all those things, but those will be the next points or advanced points. Initial point, initial starting point will be your learn Python and try to solve these textbook problems. After that, you move on to this particular part, statistics, machine learning, implementing the things, and deep learning and so on. Okay, is this thing clear to all? Any doubt in this particular thing? Yes or no, guys? Have you guys didn't have breakfast? Able to see the energy? So now where to start? How to start? Okay. For this purpose, so this is Petroleum from scratch, as initially mentioned. This is the particular social initiative that I run with my couple of friends, couple of colleagues. So here, what you can see, some of is it same for petrochemical engineers? Yes, Shreel, it will be same for any particular domain. Only the thing is that your second point, your textbook will change. Now it will be your petrochemical textbook. Apart from that, it will remain same for all domains, not only petroleum engineering, petrochemical, also your mechanical, civil engineering, electrical engineering, all the things. Because in industry, what we are doing, we are only solving the use cases of different industry, right? So half of your work is already done, because we already have playlist for learning Python and your basic NumPy pandas and all those things. So if you want to learn from there, you can do that. For example, this is our Python playlist that have around 85 to 90 lectures. And once you are done with this, you will be good in Python. Right, I will share the link for this particular playlist. And start your Python from this particular point. This will be your starting point. If I'm mentioning in the chat box. Now, once you are done with Python, your next step will be learning your data analytics libraries. different libraries are there, right? NumPy, pandas, and all that. You can learn from here, and this particular playlist have some of the minor projects also. You can see some of the projects are also there, so you can learn from here. Data analytics part. Data analytics. Now you are done with the first point completely. You know data analytics, you know Python. Now this thing you have to do by yourself. Pick up a textbook, try to solve a problem, create your Python code. But remember, you have to use GitHub. GitHub is basically a store. GitHub is basically, you can say, a place where you can store your code. For this particular thing is your GitHub, right? Here you can create your repositories, different repositories also, and not only you're storing the code. GitHub has many different applications, but I'm not getting into that. Just remember that it is the way for storing your code and sharing across people. Store your all the code in GitHub. Make it just like a portfolio so that, and mention this GitHub profile in your resume, so that if somebody is hiring, he can directly review your thing, that what things you have worked on. For example, I have this particular gold from Jurassic repository that have some of the this particular second point thing. This is from 3 years back when I was learning. So it has some of the applications, some of the minor mini projects of oil and gas. You can kind of see it from here. If you want to just do like this, create your application, store in GitHub, and share across LinkedIn. You also need to use LinkedIn. Okay, so I can share my profile if you want to go through the different codes that I worked on. There are different libraries. There is also this one well-log analysis library known as Valley. You can go through them time by time. And if you get stuck somewhere, you can always reach out to me on my LinkedIn. So again, here, okay, LinkedIn is also mentioned here, so I will share this particular link also. So this particular thing I'm showing, because that by using Python, you can do different things across different domains, reservoir engineering, or logging, or production engineering, anything. Already predefined libraries are present for doing the things. You just need to get started. So now where we, our second point is done, right? Now starting your statistics. So for statistics, I will recommend this particular guy, whose name is Krish Nayak. Go through his channel, and again there is a playlist. There are playlists for different thing. Not get involved in other things. For statistics also there will be a playlist. I will share the link. Let me find. Learn your statistics from here. This 8 video will be enough for you for statistics. After that again, machine learning playlist is also present here. Complete machine learning playlist. That. There is this machine learning playlist. You can go through this. What I'm going to do, I'm sharing this particular playlist here, link itself. Go through them. Machine learning, go through machine learning, and there is deep learning playlist also. If you want to learn deep learning at the go, you can do that also. And once you have idea about machine learning, and by going through this particular machine learning playlist, you will also have your own code of the different machine learning algorithms. Now your next step is searching for use case. Just go on one Petro. Okay, it's one use case is this like that. For example, here they have used regression and machine learning for doing your production forecasting. Try to read the paper what they have done. You will not be able to assess this. Just copy this DOI, open your Sci-Hub, and download the paper. I'm not very sure to show how to download a paper. Do that, try to implement the paper using Python. You can write anything, machine learning. Okay, so that you'll get a lot of papers. Once this is done, you put all your code where? In GitHub. Create a LinkedIn post so that you can come into the what you can say who are hiring recruitment team can see that okay, this guy is working on this particular thing, and if they have opening they can directly reach out to you. This will be your complete pipeline, how to start from scratch and how to get a job in data science industry. Okay, any doubt? Any doubt, anything you want to ask, any query? I'm done from my side. Now it's all over to you guys. If you have doubts, anything you have, any type of query, not only related to data science, any other thing you can ask me.
That was really an informative session, sir. If anyone has any doubt, can unmute their mics now and ask.
Okay, so Daksh is asking, petroleum industry data doesn't often has a constant and linear data set. So is it possible to make program of such irrational data? You will never get a clean data across any particular industry. Okay, so that is the process itself, how to clean the particular data. So if you see, okay, let me tell you the life cycle data science project, how a data science project looks like. Okay. So your first step will be the use case definition. Use case will be defined, right? Use case will be defined. After that, there will come data to you, and this data can come from various sources. For example, if you are working for a service provider, client will give you data, right? Client will give you data. Or if you are working for a product company itself, so your company will give you data. And if you don't have data, then you have to build a plan how to gather data. Now, this particular data is never clean. This is never clean. This is a job of data scientist to clean this particular data. And that's why your core knowledge comes into picture. For example, you have, let's assume you have production data, right? You have some production data from a particular well. And there are some points. Let us assume you have QO, oil flow rate. There are some particular points where your flow rate is 0. Now you have to see across different other things also, your choke pressure, your well your PWF and all those things, and try to figure out whether this particular thing is a shut in. Sorry, this particular thing is from shut-in condition or by default it is the missed data. Try to figure out that and try to fill this particular data. So you will never get a clean data in data industry. There are no free lunches. In the similar way, there is never clean data in any industry, not only in oil and gas industry. So job of data scientist is to clean that particular data, make this dirty data ready, dirty data, clean it, make it a clean data, then feed this particular clean data to your any algorithm, machine learning, deep learning, that can be anything. Because if you feed dirty data inside it, your results will also be dirty, waste in, waste out. Daksh, I hope I answered your question. Okay, any other doubts? Any other doubt, guys? And also you can use ChatGPT in your learning process. So this can also be your guide. Just write your query and it will give. all the things. Okay, so ChatGPT also try to use.
Okay. Thank you so much, Jaiyesh, sir, for conducting this workshop and sharing your insights about data science and Python. I would like to extend our thanks to always supportive audience for participating and making this workshop a success. This session is officially over. You all may leave now. Thank you.
Thank you all. Have a good day. Happy learning. Take care.